All right, I want to approve the product rule here. Some of you will never need to be able to prove the product rule, but some of you may, become mathematicians, and we need to teach you as well how to do proofs and to see these things. This proof, I don't really think sheds much enlightenment onto why the product rule works. Um, it's just a proof that it works. Um, Enlightenment will come in Calc 3. There's a day in Calc 3 that I call Calc 1 Nirvana, and all of this will make sense all at the same time. Anyway, but we can still get an idea of why this works from this proof here. So what I'm going to do is I'm going to say that y prime is equal to, by the definition, the limit as h goes to 0 of, this would be f of x plus h, g of x plus h minus f of x, g of x. That's my function with the x plus h plugged in. That's my function with the x plugged in. And this whole thing divided by h. Okay. Now, the next step, someone at some point in history was pretty clever, and they thought this up and they told their students about it, and then those students told their students about it, and so on, and it comes down to me, and I now tell you about it. Someone was really clever. What I'm going to do is I'm going to add 1. No, I'm not. Adding 1 would change the value. I'm going to add 0. So here we go. I've got f of x plus h times g of x plus h, and the minus f of x, g of x I'm going to put over here on the end. Okay, and I'm going to add and subtract the same thing in the middle here, and so I'm going to subtract f of x plus h times g of x, and I'm going to add the same thing, f of x plus h times g of x. Okay, so I added 0 to the numerator. That doesn't change the value, it just changes the way it looks. Okay, but it's set up in such a way that these first two terms in the numerator now have an f of x plus h that I can factor out. So then there's a g of x plus h minus g of x. And in the second part here, there's a g of x that I can factor out, leaving an f of x plus h minus f of x. All right, this is still all over h, and I still need to take the limit as h goes to 0. So, okay, what I'm going to do now is I'm going to break this up into two different, the numerator is a sum here, so I'm going to use the distributive property and break this up into two fractions. So I've got an f of x plus h, and I've got a g of x plus h minus g of x all over h. Now I can choose to put the f over the h or not. I mean, the way you multiply fractions together, of course, if I just think of this as over 1, then you'd multiply the numerators, multiply the denominators. So I'm choosing to write it like this, although it's in the numerator. Likewise over here, I'm going to do the same thing with this g of x. I'm just going to write it out in front, and then put this other stuff over the h. So f of x plus h minus f of x over h, and oops, and then I drew the line long enough to put the g underneath. But I mean, it doesn't matter whether that g is out in front or up on top. You're multiplying by the g, and it's being multiplied in the numerator. Okay, and then I need the limit as h goes to 0 of this whole thing. Okay. Now, I'm going to use some limit properties and say that the limit of a sum is the sum of the limits, and then each of these is the limit of a product, and so then I can do the product of the limits. Okay. So this would be the limit as h goes to 0 of f of x plus h times the limit as h goes to 0 of g of x plus h minus g of x all over h. I'm hoping that might look familiar. Plus the limit as h goes to 0 of g of x times limit as h goes to 0 of f of x plus h minus f of x all over h. Yay! Right? So I broke this limit of a sum into the sum of the two limits, and then each of these is a product, and so each of the limit of a product is the product of the limits, and so I have this. But each of these now I can evaluate, because as h goes to 0, this looks just like f of x plus 0. Well, that's just f of x. This one right here, well, this is the definition of the derivative of g, right? The limit as h goes to 0 of g of x plus h minus g of x all over h. Well, that's just the derivative of g. Let's call it g prime. Likewise here, well, as h goes to 0, that's just g of x. And here, this is the derivative of f, right? It's the definition. Limit as h goes to 0, f of x plus h minus f of x all over h. That's f prime of x. So there's your product rule. The derivative of the product is the first function times the derivative of the second, plus the second function times the derivative of the first. Okay. Like I said, at some point in history, someone was clever, figured out how to add that 0 in there, came up with this proof. It's a slick proof, but I don't think it really adds understanding of why. We'll be able to see the why eventually, but in the meantime, it's not too hard of a rule to remember. Anyway, there's your product rule.